Hi, today we're going to talk a bit about refactoring legacy code. I did recently upload a very small video about some of the things that, in my experience, I feel are very important if you're going to tackle something like that. And just as a quick review, those things were first and foremost, understand thoroughly the legacy code. Know not just what it does, but also how it connects to the other pieces of the code base. Two, set a goal and stick to that goal. Your goal probably isn't to rewrite the entire thing, but something much smaller, like make this bug over here easier to fix. And then three, whatever changes you make, be sure to cover them with tests. And the reason for that is you're working in a code base that someone's probably using live. There's features on there that were probably working. Maybe there was a bug or two, but people have been using this code. Your client doesn't want it to suddenly crash because you introduced a new bug. And even sneakier, those bugs that don't cause crashes, but that cause logic errors that weren't there previously. So those are some key things to keep in mind. But today we're going to talk more in depth, and we're going to start all the way at the top. How do you even get to the point where you're going to refactor legacy code? Because first of all, businesses don't want to rewrite their entire code base. Mentioned it a second ago, but they're already using the code and it's probably mostly working. Now, why might you be here at this point where we're actually considering doing some refactoring? Well, maybe there is a bug in the code and you've been asked to fix it, or maybe you've been asked to write a new feature, or even modify something that's already there. Well, you get into the code and you realize pretty quickly that things are really tangled and you can't even see where to start to find that bug. So you might determine that it makes sense to refactor a small portion of the code so that it's easier to find the bug, it's easier to cover it with unit tests, and it's going to be more maintainable going forward. So you're reducing the likelihood of that code that was particularly buggy from having new bugs creep in later on. Or maybe it's a new feature and you find that you are reusing a calculation, or you're reusing some set of logic that's being used over here. Maybe that logic's being used in multiple places and you're not feeling very comfortable about copying and pasting it to yet another location. And that's a great reason to refactor, because let's say that calculation changes. Maybe it's a business logic calculation, and the business decides they want to change how they are doing that calculation. If you have it in one place in your software, then it's an easy fix. But if you've copy pasted it all over the code base, you're going to have to find each and every instance of that and fix each one. That opens up a lot of opportunity to make mistakes, huge mistakes. And maybe some of them won't be easy to catch right away. Remember, it's a logic change. Those are harder to find. So sometimes there's no errors, nothing's crashing. It appears to work, but then at the end of the month, the company realizes, oh, this one figure here isn't adding up, but these other four are fine. And now you have to go fix it. And there's potentially more that you have to fix depending on what the calculation was for, that you're going to spend way more time going through and patching things up than you would have if you just did a simple refactor to use that calculation in all 5 parts of the code base. And sometimes that might seem like, oh, well, it's just 5 parts, I can keep up with that. But what if you're working in a huge code base with hundreds of other developers, and there's not even one developer who knows every single bit of code in that project? Well, then you're definitely going to want to think about not copying and pasting bits of logic and calculations that could possibly change in the future. That's going to need to be something more central. So that's another good reason to refactor. Another good reason to refactor might be same scenario, slightly different. You're adding a new feature or changing an existing one, and you realize you really need to support this thing with unit tests. But the code, the existing code, the legacy code that your new feature or modified feature is using isn't very testable. So you might need to do a small refactor to make sure you can actually test that code. And by the way, these are all things that are going to make your job go faster. So in this case, these types of refactors, these are the types that the clients are going to be fine with. Um, they're going to aid you in fixing the bug. If you didn't refactor, maybe it could take you a week to fix it, but if you do a quick refactor that takes a day, now you fix the bug with just one more day. So you're getting a cleaner code base. The client is actually saving money in the short term. But then in the long term, that piece of code is less buggy because it's easier to deal with. So in the long term, they're also saving money. Same thing with a new feature with that repetitive code. That type of refactor usually doesn't take very long to do. And in the long term, it's going to be beneficial both for the code base and for the client who's concerned about paying money to get all of that work done. And the same thing as well in the third case where you're doing the refactor to make it more testable. If it's more testable, then those potential bugs, whenever you go and you change the code and you forget about something, some edge case that was covered by your unit tests, it doesn't matter as much because your unit tests are going to fail and show you, hey, when you change this thing over here, you didn't realize it, but you broke one of your existing methods. And so that's also going to ultimately save the client money. So those types of refactors aren't really something that you have to convince the client is necessary. And those types of refactors are essentially a part of the story you're working on. You're going to get it done faster. You're going to deliver a better product. They're going to benefit both short term and long term. So the other types of refactors, which is the entire code base is a mess and I want to change it, that most likely is not going to happen unless, of course, they have an increasingly buggy application, and every time they fix a bug, they turn around and there's two more. And or perhaps it's getting costlier and costlier for the client to add new features or modify existing ones. In that case, they might actually be ready to commit to a larger refactor because they're realizing that by not doing so, they're ultimately losing money. So in that case, it's not going to happen very commonly. So today I'm mostly going to focus on those smaller refactors, which might be a part of your daily work that you might be finding them very common, very useful, very common. But what should we keep in mind when we work on those? If we go back to the short little video I did before, the first step about understanding the legacy code, that is 100% important when doing any of these smaller refactors. Because one, you make one change here. Let's say you're adding a new feature, you see some code that you can make reusable, but you didn't really fully understand how the original code was using it, and now you've broken something. So you can see really quickly how understanding just that small piece of code is really important. And in that case, maybe it's not the entire code base, but it's a feature. You need to thoroughly understand that feature, how it is using that code you're about to change, and does it actually still work once you make that change. So doing some digging, some pre-research is pretty important at that stage. But the other thing that might be helpful, even at this stage, even though we're not doing a major refactor, and even though you're not going to put a lot of time and effort into this because the client is not going to pay you to refactor their entire code base, it might be a good idea to have in the back of your mind what a more ideal code structure would look like. Now, ideally, if you could do this right, you could actually take a few days and create some flowcharts and really think through the design and come out with a really good architecture. However, that's probably not the case here. You probably only have a few minutes to do that you can actually spare to do this. That would be reasonable. So don't think of this as something that is, so to speak, written in stone. It's just an idea. Have an idea of a bigger picture of what would a more ideal architecture look like. This code is in this state now. If I were given the opportunity to make it ideal, or at least to improve it greatly, what would that look like? And it's not going to be a great design because you're just giving it a few minutes, but give it some thought. Have that in mind. And then as you're working on those smaller refactors, you can keep that picture in your head and think about slowly nudging it there, but slowly nudging it there in ways that isn't actually going to break the entire code base. Because you can't start tearing things down because you're trying to build this other structure, but you can gently nudge things closer and closer and closer to a better architecture. And I said ideal earlier, but that's really wrong because you didn't put in the time to come up with an ideal architecture. You just sat down and thought a second, this will be better. Let me move it in that direction. If it's a project that you are working on more long term, then maybe you can actually give some more thought into what the ideal architecture would be. And then you have a better roadmap as you do these smaller refactors. But the idea here is you're not building it, but every time you get into the code base, you can make things slightly better. And each time you make things slightly better, the next time you come back to add a new feature or fix a bug or modify a feature, it's going to get easier and easier and easier because you're going to realize that this piece of code that you needed is already there and you can just simply reuse it. Now you're turning slowly. Probably you have a ton of rubble, and then here in the small little corner, you have some nicely constructed blocks that you can reuse to build some nicer structures that have really end up being nice, solid, maintainable features. And yeah, you just have to ignore all of the rest of the rubble for now and just focus on that area that you're in and improving that. Of course, that is a huge compromise for anyone who loves clean code because you're looking around and seeing the mess. But if you focus on, hey, I'm making this thing better, that can help. That can help because even if it improves one feature, then you're giving a lot of value to that client. And so that would be one thing to keep in mind when refactoring legacy code. And that kind of goes both into the categories of understand the legacy code, because not only are you understanding it as it is, but you're also understanding it as it could be, a potential better version of itself. How would that look? How would that work? How can I slightly nudge things in that direction? And at the same time, you're setting a goal and keeping that in mind as you're working. Now, this isn't your main goal. Your main goal is probably something as simple as fix this bug, and we're going to refactor in order to make that bug fix easier to do. That is your actual goal in this whole thing. But you have this other goal that is pretty much saying, fix this bug, make it easier to fix with this refactor. And with this refactor, I'm going to nudge the code base slightly in this direction. Now it gives you a bigger roadmap of what you're trying to accomplish. And then, of course, some of the things that could happen, there's always going to be surprises. You're always going to dive into a bit of code and think that you have this great plan, and you get to work and all of a sudden you find something that just completely destroys your plan, or at least alters it a little bit. So it's important to stay flexible. Keep in mind as you are planning the refactor that there's going to be some research involved. You can't just start coding. I mean, you could just start coding, but it's best if you actually do some research, understand the problem, understand the code base fully, both as it is and a potential improvement, an improved version, understand the problem you're trying to fix and how refactoring it in this certain way is going to ultimately make things just a little bit better. And at the same time, while you're doing all of this, don't forget about those unit tests. If you're working in a feature that someone's already using and you've changed the code, it's so much nicer. It looks like an actual structure. You can reuse it. It's great. It's pretty. Yay. But then you find out it doesn't actually work right. That could be a problem. So that's really where those unit tests come in. They work as a safety net so that you can do all of these changes without worry. In fact, it would probably be best to start with your unit tests, make sure they pass. If they don't pass, then maybe there was some edge case that the original code didn't cover, and that's good to know. But if they do pass, then you know, okay, this code worked. Here's what it did before. I want to make sure it still works afterwards. Now, if you're doing a bug fix, your unit test might fail, but you want it to fail in the way that you expect. If it fails in a way that you don't expect, then that is good information and you can pursue that, and that can actually help you as you're trying to solve why this bug is even happening. But that aside, you create your unit test, you look at the code structure, fully understand it, then you can dig in and start making those changes. And at the very end, you run those unit tests again and make any other changes that you need at that point. And going forward, you will have a better code base, which is the whole idea of this. But now you've made those changes without crashing the entire site or causing unexpected hidden bugs that won't be discovered until 2 or 3 months later. Now, one thing to keep in mind when you're doing these refactors, sometimes you're going to have to do things in layers. Maybe you have an idea for refactoring this feature and you realize though that you could potentially introduce a bunch of new bugs because there's a lot of complexity going on. The more complexity in the project, the more important it is to break things down into smaller pieces so that you can fully understand that set of work before you move on to the next. One thing that I found useful when making changes with some really complex code is think of your commits as a story. So if you think of, I want to accomplish A, B, C, and D, or let's set that aside. I want to go from state A all the way to state D. Now, in between A and D, there's other states. So you can go from A to B and B to C and C to D. And that could be a way that you could break it down. So in your first commit, pick a small goal that gets you closer to your final state. Like maybe you are simply moving this bit of code that is going to be reusable into its own little place, but you're not actually making any changes yet. You're just creating a new method with this reusable bit of code, and that's commit 1. And now commit 2, you actually replace that original, every place that used that repeated code, whether it's 2 places or 10 places, you go through there and you replace it to call the centralized code. And then in step 3, you could build your new feature with that does actually call that code that you're reusing. And so then in that way, you have those 3 commits that really show the story of what you did and help your reviewer as well to understand each step of the way, what you did and why you did it. And that's just a couple of things that I've found in my many, many years of software engineering, and what I have found works for doing complex refactors without breaking the code base. So I really wanted to share that today and hope that all of you find that helpful, and talk to you later.